This is taking its sweet time, but I think we're there. So I just wanted to run you through a quick little example kind of related to what you're going to have to do on that worksheet we got at the end of the period yesterday. So what's going to be really important now is paying attention to the types of graphs that you're dealing with. This is velocity versus time graph, and I can see the slope is going down as the graph goes to the right, so it's got a negative slope. Okay. Give a written description of the motion. Okay, so I'm not going to describe the motion with a negative slope. I should talk about the direction this thing is moving. This velocity is always greater than 0. So object is moving in the positive direction. But if you look at the velocity starts out at 6, then it's 4, then it's 2, then it's eventually 0. Okay? So this thing's moving in a positive direction while slowing down. Sketch a motion map. Oh, gosh. So again, 3 dots is sufficient on these motion maps. I might add another one here. So initially, I'm going fast. I'm going a little slower. Going a little slower. I want to add in my hollow dot arrows. I notice some of you draw them at the end of the arrow. Some of you draw them at the beginning. So whatever works for you is fine with me, as long as they're there. And I've got tick marks to show that the velocity is changing in a really regular way. This wants me to determine the displacement from time 4 to time 8 seconds. Okay? And visually show how displacement shows up on this graph. So we have to remember back to the constant velocity particle model that displacement is the area between velocity graph and x-axis. So basically, I want to figure out where's 4 seconds, where's 8 seconds to be there. And if you look at this graph, the only difference in this unit is the shape that I'm dealing with. All right, hang on 1 second. All right. In terms of the dimensions of this triangle, the height of it, kind of tough to call. It looks like it's partway in between 2 and 4, okay? And then the bottom edge here is at 0. So I think the height of it is 3.5 meters per second. Oh, I'm sorry. You're right on. That's 3. Right in between the 2 and the 4. That's how right in between 2 and 4 works. I was distracted by Eva and Kate's talking, but they stopped, and so then it really threw me off. So please keep talking about stuff not related to class. All right. So then this base here goes from 4 to 8. So my base is not 8. My base is 4 seconds. Okay. Clean this up a little bit. 3 meters per second. It's a triangle. So another equation you're going to need to know in here is the area of the triangle is half of the area of a rectangle. If we had a rectangle that was 3 by 4, You can see it'd be that whole thing there. This triangle is half that area, half the area of the rectangle. So I just take 1/2 times 4 seconds times 3 meters per second. And you can see how with this, seconds is going to cancel out. And that's why I say that this area represents the displacement, because my answer here is going to be Peaches 2 times 3. Peaches 2 times 3. Oh, okay, cheers. 6 meters. So that would be my displacement there from 4 to 8 seconds. I'm giving you notes. This is an example problem, and then you're going to go get after it. Trying this thing called teaching. So we'll see if it works. All right. So that's 6 meters. And then it says it wants me to find the displacement from 0 to 4. So if we look at the area here from 0 to 4, what are you seeing? All right. Peaches, what do you see? Gigi, what do you see? What's the red shape? Okay. Abdul, what do you see? All right. So you West High math kids see trapezoid, but I see a triangle on top of a rectangle. Okay. You're welcome to see it however you see it. All right. You could just find the area of this triangle and add it to the area of this rectangle. Or if you want to see it as a trapezoid, the area of a trapezoid is base 1. That would be this side over here, plus base 2. That would be this side over here. That's divided by 2. And then you take that times h. And it's kind of awkward. Like if I tip my Chromebooks, oh, that doesn't work. But yeah, if you tip it sideways, then it looks more like height. So that's how that goes. So B1 is, poop on it. 6 meters per second plus 3 meters per second divided by 2. And then I'm going to take that times 4 seconds. So that's going to be 9 meters per second over 2 times 4 seconds. Commutative property of math, is this 18? And again, if I follow through with the units, seconds cancels out seconds. That's 18 meters. Okay? So this is in the notebook if you need to refer back to it. I guess I do need to look at one other thing. I feel her. All right. Determine the acceleration of the object's motion. Work in units. So, hey, if we want the slope, I feel like I'm talking to my sister on my phone. I don't ever have to. It's like I call her speakerphone because you don't actually have to use speakerphone. All right. So X, this would be 0 seconds. This would be 6 meters per second. And then down here at the bottom, this is 8 seconds, 0 meters per second. So when I calculate my slope, somewhere along here, slope, I'm going to have 0 meters per second minus 6 meters per second. That's going to be divided by 8 seconds minus 0 seconds. Now, it's not always going to like start at time 0 or end at a velocity of 0. So sometimes the slope calculation is a little more exciting. 0 minus 6 is 6. No. It's negative 6. 8 minus 0 is 8. Now I'm not taking meters per second times seconds. I'm taking meters per second divided by seconds. So units wise, I'm gonna end up with meters per second squared. And then number wise, 6/8 is 3/4. So this is negative 0.75 meters per second squared. That's the acceleration. Okay. Then it wants me to sketch a possible position versus time graph for this, but I really can't be bothered. So this is in the notebook. If you need to see it closer, hopefully the notebook works for you now. But what I'd like you to do today is use the time you have remaining to work on that sheet we got yesterday. If you weren't here yesterday, let me know, and I'll sort you out with this thing. Solving with the velocity versus time graph. So the axis is already on here. Based on the numbers they give you, go ahead and draw the graph, and then see how those numbers fit in. Like sometimes they tell you the displacement, or sometimes they tell you the initial velocity or the final velocity. So put that stuff on the graph and kind of use it to frame your solution, if you would. You bet. You're good.
Okay, I just helped him put these things together. I just remember. I know how to do this. I just don't teach anything that was useful. Except for
Boop. I have a seat for you if you want, friends. Zabdul is very nice. Oh, if you had questions, you could talk to each other. I just feel bad with Aya over there in the lab now that we chased off her friends, Drew and Shintaro. What's up? I'll be there in a second. I'm taking attendance. Kate, where's your group?
Graham's over there.
By Amir, your other group member, so go join them. And then Eva can work with her group, wherever that is.
My group.
What is your group?
Kiana's not here. She didn't even come to Kirkwood and have a
Dude.
Yeah, kind of rough.
Come on, Kiki. Tomas. Poor quiet Tomas in the back. So if Kate and Tomas just swap, you're good.
I think that's okay.
Tomas is really rooted to that seat, though. He hasn't changed seats all year.
I've moved like 4 seats. I think me and Kate can reach.
Bill's here, Angie's here, Austin's here,
Yeah, maybe I'll have like
P. Doyley is here, Daisy's here,
gosh.
So it'd be
is here.
yeah, so it'd be 28
She need coffee?
Can I stand? Can I stand?
minus 0.
What do you need?
It's for something for
Just for a
game day.
TikTok?
Yeah.
Oh, okay. Or you like sporty
so
enough,
we
you're
do
just
the
gonna like
velocity
straight up
and then you do
jump onto this thing.
20 minus 0.
What's happening? Do I need to move my coffee?
Hardy, you have to be in it.
Or it'll change, yeah.
Is it a blue slip?
And
Are you jumping off? Do I need to move the stool?
then
I have to say happy game day? Or do we have like a time? Like, are we gonna like?
Wait, should we get the entire class to say it?
No, probably not.
All of you should look like you're focused and working, so it's just really weird. Like if you're aware of the video, it's less funny. If you're just doing stuff.
Okay, Harding, you ready?
Yep.
You're saying it. It's game day.
whatever that is. Meters per second squared.
Happy game day.
That's really lame.
What?
No, I thought she
It's
was gonna, like,
great.
stretch or something.
Did I say it loud enough, or do I need to be louder?
I thought that was
Do I need to be louder?
Okay. That was really lame. Thanks, Riley.
What?
Appreciate it. Riley said it was really lame.
I think you should like jump off.
Lame
the
people
arrow.
think things are lame.
Do you think I should?
Yeah.
And I'll just basket catch you. No.
Just not get hurt. Just
How about don't?
you want me
how
to,
about don't
you want
get,
me to fall? and
Trust
then
fall?
catch me?
Don't get
Yeah.
hurt.
Let's
No.
do that.
How about don't get hurt on game?
Yeah. Maybe tomorrow though.
Who cares? Let's keep it.
Who,
Everything for game day.
whose hopes and dreams are we crushing tonight?
Western Buttes. Yeah, them.
I have to 5'6" bro.
Bro, all of them are like 5'8".
So
So you're playing the five? Like, what's that all about?
Yeah.
Fair enough. That makes sense.
20 by 28.
The shortest person is 5'6".
That's what I was.
Still hard.
Taller
So
than
we
me.
saw the first one.
What up?
Hold on, I can.
What?
Grace, what are we gonna
and then
do?
Slope?
They said it's lame. It's
You
kinda
could like
sucks.
erase the word average. And it,
Let's
it
check
just
the
wants to
two
find the
We
acceleration.
can use this here.
How do I find the acceleration?
Slope of the graph. The thing I just did.
Oh, but we don't have to really know.
You might have to figure out some more numbers. Because you got the area of the graph, which is the displacement. Like,
So yeah, we solved the first. Oh wow, we're basically done.
Oh, you already said
Okay. So did you get 1.4? And then how did you get 20
Honestly, I really want to know what my strength is.
for the one?
It's like playing.
I'm just wondering if it's
Oh, I guess that makes sense. So maybe we were overcomplicating it.
like that's when it sat the distance. That's the big difference. It's 28 miles per like meter per second.
Oh, so
It's like if you're like driving at like 28 like miles per hour, and you have like times it by the time. I
yeah,
think it is 28
Mr. Harding.
which is just not 60 now.
meters. Say this is 28 by 20. Yeah.
Yeah, I'm doing the 5. Because I didn't do that. No, I did 5 Yeah, before the last one. And then, so flying to the
Yo!
car has 30 miles per second. After 6 seconds, it's 40. So it like goes up and then it goes down.
does that seem likely?
Oh wait.
Yeah, time 0
So it would start like
Okay,
up here,
at 30.
and then it would just drop.
6 seconds goes down to like you just
So it would just drop like this, I guess. Mine's more exaggerated though, because it would be like up here.
I don't know what we're doing, and I don't know. Never mind. I wore my glasses.
So our acceleration is just
Yeah, no, I like
30 minus 0 again.
So what's the average acceleration?
Yeah.
What do they do?
14 minus 6.
Well, I know that you.
Wait, oh wait, no. Because we have 14
Like
meters per
half
second
the
now.
times the height, but I don't. What does that find you?
That finds the area of the graph. What's the area?
What did you say it was?
I got like displacement minus.
When I wanted the acceleration, that's when I did the
Oh
slope.
yeah, I think that's like it's gonna be
Okay, well, I have another question.
That's why I don't do
minus
that.
30.
I've had to re-explain. Teaching is not talent. That was not good. See? Yeah. This is kind of like back. So if you remember back.
Right, so like.
Meters per second.
And this particular problem was no different. Do you remember when we had all those graphs?
Its acceleration was constant during the 6 second time interval. How far did it travel? So, what's going on?
Yeah. We don't know that.
Imagine if we do that. P doesn't make sense too.
The way that
How did you do
the way
that?
that changes.
Oh, you know how to do it. Yeah, it's kind of confusing. Its acceleration is constant during this like second. So
Maybe if it just goes down.
would we multiply -2.67 times 6? But what if it just give us?
Like a little more.
I got this. I don't know. That's stuff though. Oh yeah, you can't have it.
Can accelerate from rest to a speed.
How far did it go?
So,
How do we find how far? What's the word
so
for
it'd be
how
like this.
far? One word with the distance, or what's our fancy word that we use? Yeah, how do we find its root? Yep. What kind of shape you got?
Triangle.
Mr. Hardwick.
Yeah.
So it just be
The name that is
Average acceleration.
wait. Oh, I'm
I think
really
average
confused.
acceleration.
This has thrown me. It'd just be 30 minus 40.
I don't get how to do it.
As long as you fill it with water.
Yeah.
But we cut it off at 14.
Oh,
maybe. So then it'd be like 16 here for one side,
So it'd be 6 for the bottom. What
and then
distance?
16 for the other
Okay,
side.
you guys love me.
No, this means that.
Okay.
So I don't know, 48?
I just did 28.
28.
48.
What's this?
Meters. You can
So
check
it
from another
goes
group as well.
1.4 meters, so then you'd be 20.
The force is moving at 75 rate.
What is this time?
And then to get the acceleration.
So it's the same thing again.
I'm just
Sorry.
really
You do
stupid.
a gradually
Oh,
what distance does it travel? But
It
it
does
already
like me, but
Oh, it's slow.
no, actually, it's just really comfy.
So then, wait,
This acceleration is so
You can fit like 15 layers under
is that one
it.
why it's straight, but then this one is like.
So they expect me to have a little bit. Yeah. But
Cool.
it also protects my fingers.
How long does it take the bus to stop?
Yeah, I gotta love it. Gotta
How do
love
you
it.
do that?
5 meters?
I did it by hand. And then I found out. Like I did like
I definitely
every 4 seconds.
I have the fingers. No, I didn't. But the sub was super annoying, and she showed us 15 on the way back.
How far did it travel up? So, 0 seconds.
She was telling us that we're not allowed to compare Ronald Reagan nowadays.
Wouldn't it just be like 20
I'm like, I was alive then, so I can only
Wouldn't it be great the whole time?
Like, what are you talking about?
I don't even understand any of this. I'm having a hard trouble understanding A. Does it mean stop to like as like a halt or like to 4 meters?
How far does it travel while it's breaking?
Oh, oops, I'm looking at A. I'm sorry. Yeah, so you said that it's breaking the entire time up until 4 meters.
Isn't it like slowing down?
Is this due tomorrow?
I mean,
So if we divide 20 minus, or can we subtract 20 minus 40? It's just 16.
Joe,
Is it okay if I get a slope of like -2.67?
is your graph trending downward as you go to the right?
Yeah.
okay, should we take that one?
Yeah.
Oh, okay. I didn't know what was.
So a dog runs down the driveway with an initial speed of 5 meters per second for 8 seconds. Then uniform rate increases his speed to 10 meters per second in 5 seconds. So uniformly means that it's gonna be constant,
It's B again. He's B.
right?
What do you want to know?
Acceleration
Then
constant.
and the first part is but then the second part is.
So.
Yeah, the second part.
Yeah, the second part's constant, but the first part's standard.
It's a graph.
Increase.
Yeah, but is it talking about this shape or is it talking about that shape?
What's that?
Oh, yeah, I thought it
Yeah.
was like that.
So for 8 seconds, oh, we need to mark the. I didn't mark my graph, so I didn't know how it was.